Let's keep practicing more of the Lewis structures. In our previous video we stopped up to here. We were seeking for all the elements to follow the octet rule, provided they are in the second period, which is going to be most of the cases, but be careful, beyond the second period the elements do not have to follow the octet rule, so you can add more than 8 electrons. But now let's see more cases. In cases when you have several possibilities of bonding, different kinds of charges, etc., etc., and also something that we call resonance. So in this case, let's start building the Lewis structures of cyanide. In this case, so carbon brings 4 electrons, nitrogen brings 5 valence electrons, but you need an additional electron to justify the negative charge. Okay, so we have 10 electrons around it. Alright, so first you may want to say, well, where do I put the extra one? Let's see. But first let's see if carbon has the 4 electrons, and I'm going to put it on the additional electron here, and so each of them will have 5. So let's start building bonds. So this one comes here, this one comes here. Is that enough? Well, this would be carbon 1, 2, 3, 4. I have a single bond, and that would be a nitrogen. Nitrogen 1, 2. Well, none of these are following the octet rules. Both carbon and nitrogen have 6 electrons around them, so let's add more. 1 and 2. Now that would still be 7 electrons, so let's add all of them, this 2 and this 2. So that means you will be sharing 3 pairs. So 1, 2, 3 pairs, and then this is left alone here, this is left alone here. Both of them are following the octet rule. Now let's see, in terms of charge, where does this extra electron falls? Well, carbon follows the octet rule, and so does nitrogen. However, notice that nitrogen has 1, 2, 3, 4, 5 electrons, therefore nitrogen is neutral. Notice carbon that has 1, 2, 3, 4, 5 again, and it should have 4 for a neutral, so we're going to put what we call the formal charge on carbon. So the Lewis structure of cyanide will be something like that. Okay. The same approach can be for carbon monoxide. If you do the same, number of carbons, so in this case it's neutral, so carbon should have 4 electrons, oxygen should have 6 electrons, and if you start building, how many atoms will you end up adding? So notice that if you can add with different rearrangements, but the preferred one is the one that, again, maximizes the number of bonds. We want to build as many bonds as possible, provided that it follows the octet rule, and also minimize the formal charge. And if there's supposed to be a charge, in this case, let's put it where it should be. Well, in this case, we don't know, but to follow the octet rule, let's see how many electrons does it have. 1, 2, 3, 4, 5. Again, the negative charge falls here, and for oxygen has 1, 2, 3, 4, 5. It should have 6, so it's missing 1 positive charge. This is the Lewis structure of carbon monoxide. In this case would be this one. This should not look very good, but good luck in trying to find something that minimizes the separation of charge and maximizes the bonds and follows the octet rule. I'm saying it should not look right because typically the negative charge should fall on the most electronegative element. So carbon monoxide is tricky in the sense of the negative charge. In order to maximize the number of bonds and following the octet rule, the negative charge is going to fall on the carbon, which is the least electronegative. In other cases, provided that it follows the octet rule, maximizes the number of bonds, if you have 2 options, put the negative charge on the most electronegative. Let's do another one. In this case, carbonate. Let's remember that the least electronegative should go in the middle, followed by oxygen. If you start counting the electrons, you will see that you need to add 2 extra electrons, and so with notice, however, that you cannot add more than 8 electrons around carbon. So this will be a negative, and this will be negative. This will be the Lewis structure of carbonate. However, notice that where the same way that I put the double bond here, it could also go on the other one. So what we will have is something that we call resonance, in which this double bond will resonate around. And finally, a last structure should be when the double bond is here. Let's negative, negative, and then 2 double bonds. Okay, so this just takes some practice. However, if you can represent your Lewis structure with a little bit of resonance, that will always be a stabilizing factor. We'll solve in class nitrate, which will be a very interesting example because it shows resonance, but the charge it shows some positive charge on nitrogen, which is not very common. Let's practice more later.